Hi there, welcome to this video. We are going to solve some trigonometric equations that appear in ratios or rational expressions with trigonometric equations. So we're going to go ahead and look at some of those today. Again, you'll be successful if you know your unit circle values for sine and cosine. You can solve linear quadratic equations and use potential trigonometric identities. So when solving a trigonometric equation that involves a trigonometric function in the denominator, any algebraic solutions must be checked against angle values that would make the denominator equal to 0, since this would create an undefined ratio. Pretty much what we do is we always look at the denominator and we find any excluded values or excluded angles because these would be extraneous solutions, answers that we have to throw out. When finding zeros of a rational function, if r of x is equal to p of x over q of x, where these can be polynomial functions or trigonometric equations or functions, the zeros of a rational function will be the same zeros of the numerator, excluding any values that make the denominator equal to 0. So essentially, when I want to go ahead and find zeros, all we have to worry about is the numerator. We just set the numerator equal to 0 because when you multiply by a denominator, if you multiply 0 times that denominator, the right side just stays 0 anyway. So the denominator is really kind of inconsequential to what we are doing. So let's look at this first example where we'll look at these ideas. The function h is given by h of x equals 2 sine of x on the interval, 2 sine of x over cosine of x minus 1. On the interval 0 less than or equal to x less than 2 pi, what are all the zeros of h? So essentially what they want here is what are the zeros of h? Well, h is 2 sine of x over cosine of x minus 1. Again, in a rational function, the denominator has no impact on zeros. If I multiply both sides by this, the denominator would go away, the right side would just stay 0. So essentially what we do is we just worry about what the numerator is equal to 0. And so this is kind of nice. We can go ahead and get rid of that multiplier of a 2, and they say, when is sine of x equal to 0? Well, this happens at two possible locations. It happens at angle 0 and at angle pi. So awesome, good, we're golden. Well, you do have to go ahead and check. I'm going to check for any excluded values. These will be undefined values. This is where our denominator cosine of x minus 1 is equal to 0. So we can go ahead and solve this. Move the 1 over to the right hand side. Where is cosine of x equal to 1? Well, that happens at angle 0. Oh man, check it out. Whoop, look at that. We're going to throw that answer out. Okay, so our only answer for this equation is pi. That's an excluded value, and I think technically what will happen there is you would have a hole, potentially. Okay, I guess if a factor, maybe not, ignore me. Excluded value, we don't include that one. Let's look at example number 2. The function p is given by p of x equals cosine x plus 1 divided by sine of x on the interval 0 to 2 pi. What are all the zeros of p? So the same question that we have here, we want to go ahead and set our function p of x equal to 0, which is cosine of x plus 1 divided by sine of x equals 0. So again, for zeros of a rational function, we only worry about the numerator. Where is cosine of x plus 1 equal to 0? We can subtract 1 on each side, and we get the solution cosine of x equals negative 1. So again, here I have pi. Cosine of x is equal to pi. And I do have to worry, okay, what are my excluded values? So check the denominator. Does this make our denominator undefined? Sine of x equals 0, where? Again, this happens at angle 0 and at pi. Oh my gosh! Look at that. So, I mean, again, we have no solution here. So our only solution went out the window. So this is no solution. There you go. Let's go ahead and give you a practice problem. Okay, here's a practice solution. I want you to go ahead and solve this one, and then I'll show you the results here in a second. Okay, hopefully on this one, again, they want all the zeros, so you're going to set your function 2 sine squared x minus 1 divided by cosine of x equal to 0. Again, hopefully you just took the numerator, 2 sine squared x minus 1 equal to 0. You should have solved, so 2 sine squared x equals 1. You do that by adding 1 to both sides, and then divide by 2 gives you sine squared of x equals 1/2. Here, maybe you ran into some issues. What you should do here is you're going to take a square root of both sides. And what this gives you is it gives you sine of x equals plus or minus. Don't forget the plus or minus. And you have the square root of 1 over the square root of 2, which is plus or minus 1 over the square root of 2. And if we rationalize, we get plus or minus the square root of 2 over 2. If you need to pause me and kind of fix if you made any errors and also come up with new solution values, please do that now. But you get sine of x equals plus or minus the square root of 2. Hopefully you recognize this as a pi-4th angle, and it's all the positives and all the negatives. So check it out. Our solution is actually going to be pi-4ths. It's going to be 3 pi-4ths. It's going to be 5 pi-4ths. All the pi-4ths. 7 pi-4ths. Oh my gosh. Okay, but just 0 to 2 pi. Just on that window. And do any of these angles, do we have to exclude them? You have to go ahead and check here. Where is cosine of x equal to 0? Well, that happens at the north and the south pole. Guess what? None of these values intersect these, so we are golden. There's our answers. Okay, so pretty straightforward. How do you find zeros of a rational function, including trig functions? Set your numerator equal to 0, solve. Just make sure that none of your solutions make the denominator 0 as well. Okay, that's our excluded values here in purple. Hopefully you learned something. Give this video a thumbs up. I'll see you in the next lesson. Take care.